All right, seems to be fine. So outside of interacting with via a graphical tool, like you see here, right? You can click on applications and they would open up and you can interact with them, right? Another way is to start what we call a terminal or a command line interface. Typically, you would do that with Command R. So I'm pressing on the keyboard, the Command key and R, right? And I can type any command here, but the one that I'm interested in is CMD, right? So this one will open a an app, right, where I can type commands and interact with the commands. For instance, you can see, if I can go and find a file browser, right? So this will be my home folder, right? And then if I type in here dir, you will see the same folders, the same directories listed. All right. Now here you can go and explore one of the folders. So for instance, this is where I keep most of my code files, right? And I have already started a Git repo for this, which is where I placed the files that I used in the previous half of this semester, right? So you see from my home folder, I went to code and then miscellanea, right? And then I can do the same here. I can say cd for change directory, and I can say code /misc, and I would go there, right? So if I do a dir here, I would see the same folders, right? So I can interact with the computer, I can interact with the machines exclusively from this window. It's something you see sometimes in movies. Hackers appear to be doing that a lot, and it's associated with, you know, not necessarily meaning well in the world of code. I had a not very close friend, more of a distant friend. Sometime she saw my my screen, and it was full of code and the command line interface, and she said, "Oh, what are you doing? You're an evil person." Right. So no, most coders, most IT professionals would know how to use something like this, right? So I'm going to create a folder for this course. I'm going to say mkdir. So one thing I could do is right-click here, and I could go and say new folder, right? But I'm going to create it from here. I can say mkdir or md if you prefer. YSC. What's the code here? What's the code for this course? Okay, Python. Good. And then I can move there. All right. And you can see that this has been created. This wasn't there, and now it is. For editing, so we're going to start working with files. For editing files, we're going to use Visual Studio Code. I use Visual Studio Code. Please feel free to use anything else. There's quite a wealth of editors nowadays. There's Sublime, there's Atom, there's Brackets. If you have money, you can buy a license for PyCharm, which is even more evolved. Actually, I have PyCharm here, but I don't want to use a tool that most of you probably wouldn't. So I'm going to stick with Visual Studio Code. And typically we open a folder which sort of looks like a project. So I'm going to open this folder, right? And then all the files that we create will be created there. And in fact, I would like to split the files into multiple folders, one per week. So I'm going to go here. And I'm actually going to go into this one, which is white, right? And we're going to use this one because it reflects more light. So I'm going to also here go into code misc, which misc, and it has code completion. I can press tab, and I can go here. If I do dir, there's nothing here yet. I can do mk dir, and I say Week1 Thursday, right? And I can have take advantage of the completion. And then I'm going to go in here and open this folder. And in here, I'm going to say new file. And today we're going to explore strings, essentially, which are aggregated data, as we will see soon. We're going to say have a file called strings.python, py, right? So this is the typical Python program. Before we go there, so I'm not going to go there quite yet, but we have prepared the ground for that. All right. So instead of running the idle interface that we were running last time, I'm going to go here and say I'm going to run Python from the command line. All right. How does it look on the screen? I'm not quite sure why I have this one here. Let me just stop it. All right, so one aspect that I want to introduce now is the object-oriented aspect of Python, right? All entities that we have seen last time, and we're going to see further, are objects, are entities that are not atomic, right? They contain stuff. They have stuff inside, right? So, for instance, if I take the number 3, right? We're very used to say 3 plus 5 has some value, right? But actually, plus is an operation that sits inside the integer, right? So, alternatively, I could say 3 add 5. Right? I can do things in this way, right? And I get the same result. And what I want to tell you first is that whenever Python sees this, right, it actually internally translates it into this form, and only after that it evaluates it. All right. So what we call this is syntactic sugar. This form, yes.
So how do you run Python there? Or you just
all right, so let me get out of here then and exit. All right, so you have to type all that. Yes.
How can we do that in Mac?
You just say Python 3. You don't have to. So Mac is a lot more programmer friendly.
Using terminal?
Yes, using terminal. I should have said that. I kind of assumed that. Oh no. Okay, I don't need this. Why? Okay, everybody managed to run the interactive Python. So as you run it, let's learn how to work with it, right? As you run it, you can get out of it by typing exit. And then the command should be in your history. So by pressing the up arrow, you should be able to repeat the command as many times as you like. Okay, is this clear? So, all right, so let me explain this format, right? So this number is in fact an object. It has stuff inside. We can access whatever is inside an object, any object. We're going to see a lot of objects from this point on. We can access it by putting a dot here, right? So we're saying 3 dot, and that gives us access to all the stuff that is inside, right? One important thing that is inside is all the operations that can be performed on integers, and they have these funny names. They have a double underscore, the name of the operation, and another double underscore. And this is just a function, right? And once I say 3.add, this is the function that adds something to 3, whatever is going to come as an argument, right? This makes it very uniform because all objects have stuff inside, operations, data. We're going to see that, and there's a uniform way of treating pretty much everything. These operations that have double underscore are not meant to be used directly. They're meant to be hidden from users, right? So whenever you want to create stuff that nobody should use directly, right? You would use this convention of putting double underscores before and after, or at least before, right? What other stuff is inside the number 3? Well, I can use the command dir of 3, right? And everything you see inside here is stuff that we have inside 3. All right, and some of the stuff is quite interesting, right? So for instance, we have a conjugate, right, which would be very interesting for a complex number. So for instance, if I say 1 plus 2j, as you remember last time, right, this is a complex number. I can say conjugate, and this is an operation. Because it is an operation, even though it doesn't take any argument, we have to use the brackets. And then as we evaluate it, I get 1 minus 2j, right? And you also see all the operations that are expected, right? So there's a subtraction somewhere. There should be a sub, right? There should be a division, true division, bit length, right? There's a denominator here. All right, why is that? Because I can say 2 divided by 7. And guess what? Denominator maybe no. Has no attribute. How do I produce a fractional number? This is like this. Okay, we'll get there. So numerator, denominator, we can use that for fractional numbers. Python has infinite precision. Just that I'm not very sure how to access it, but I'll figure out how that is possible. Okay, so in general, we can inspect any entity with dir. All right, and then we can get any documentation on an object with help. So I can say help 3. Right, and that will tell me not only what is inside, so it will tell me the type of that object, what is inside of that object, and it will provide some documentation for every operation that is inside that object. Right, so you can see the documentation and understand it. Right, now because 3 as an entity is we're used to working with it with binary operators, right? With plus minus, right? Looking at the inside of an integer is not so interesting, right? But maybe a string is more interesting, right? So as I was saying, everything is an object, right? So let's see what's inside the string. All right. So here there's a lot more interesting stuff, right? So we have a bunch of operations that are not supposed to be used directly, like len, for instance, right? So I could use, for instance, abc.len, right? And this will give me the length of ABC. But the preferred way is this one, right? So I can use len ABC in Python directly, right? And this is the preferred way. But there are quite a few others that are very interesting. So for instance, I can let's use which one is the first? Capitalized, right? So there's this function called capitalize. So I'm going to use a.capitalize, right? So I'm going to get the capitalization of that. If and it will capitalize every no, only the first letter of the string. All right, I think I was missing part of the window, right? So notice that there's a code there. So abc.capitalize. I'm wondering whether it capitalizes every word. No, only the first. All right, next one would be the case fold. I have no idea what this is. Center. Again, no idea what it is. But guess what? We can actually find out. I can actually say help of empty string.center. And if I don't use the brackets, then this is an entity that is an object, and then it has documentation. If I were using the brackets, I would invoke the function, but if I don't use the brackets at the end, I mean inspecting the object itself, right? And then I can create a string of larger width, right? That so that the current string is centered inside. So I could say, for instance, ABC center 10, right? So you see now that I have a longer string, right? And the original string ABC is centered inside that big string. More interesting stuff, right, is that I would have, let's say I want to split. So I can split the lines. All right, so I can say, and a new way of providing strings is by using 3 single quotes. And when I use 3 single quotes, I can have strings that go across several lines. So I can say, I can have A, B, C, D, F, G, H, I, right? And I'm going to close the string. And now I can say dot split lines. And what we get is a list. We haven't discussed lists yet, but you kind of understand what they are. They are a sequence of objects, right? And inside that list, we have a number of strings, 1 string for each line, right? So we have divided the original long string with new lines inside into separate strings, 1 per line. All right, and so on and so forth. So this is an important feature that we're going to take advantage of as much as we can. All strings have the same members, so I can say just dir of the empty string. All right, we have a bunch of functions that classify a character. So I can say a.isAllNum, right? And this will be true, right? If I use a special character isAllNum, I'm going to get false, right? Similarly, it's going to happen with, say, it's isDigit, right? So 3 or 2 is digit, right? It's going to be true. A.isDigit is going to be false, and so on and so forth, right? So we can take advantage of stuff that is inside an object. We're going to use that extensively. All right. Now, one important aspect of a string is that it doesn't have just one thing inside. It has many letters, right? It's a sequence of characters, right? And we can access portions of that string with a number of interesting operators. So we're going to put a string into a variable which we call s, a, b, c, d, e, f, g, right? And I'm going to index this. I'm going to say s1. And you see that s1 is b, right? The first index is 0. So s1 will be the second character in the string, which is b. We can use ranges 1, 2, 4. So the colon will give me a substring from position 1 to position inclusive to position 4 exclusive, right? That's also a very common convention across all programming languages. When I specify limits, the start is inclusive, the end is exclusive. That's always a good thing. A very interesting feature is that we can count from the right using negative indices. So for instance, if I use -2 here, right, I will get the range from the first character from the left, inclusive, to the second character from the right, exclusive. Okay? What if I want to go out up to the end of the string? Well, then I just don't specify the right limit. All right, and I will go up to the end. What if I don't want to, what if I want to go from the start? Well, I could use 0 here, but I could also omit this, right? So I can say -3 here. So we're going to go from the very first character, inclusive, to the third character from the right, exclusive. Okay? We can have a step. So I can use another colon and say that I want every second character in this range. Okay? I don't want every single character, but every second character. Okay? Everything is clear about indexing strings. The same indexing scheme will be used for lists and tuples later, right? So what we learn now is very reusable. Yes?
So how does the one it is in work again?
How is the?
The 1 colon -2 colon 2.
So we were going from the first character at position 1, right? So
yes.
it's B.
B.
Right? A is 0, B is 1. So we're starting from here, inclusive,
Yep.
to the second character from the right, exclusive. So this is the first from the right, this is the second from the right, and it's exclusive, right? So F is not in the range. And then I'm going to take every second character. So I'm going to take B, skip C, take D, and skip E. So the result is BD. Okay? Now, we have a lot of stuff inside inside the string, but there are also functions that are outside of these objects, right? And the question is, how do we know what's outside of these objects? Well, if I do a dir with no arguments, all right, I'm going to see what's available at the top level, right? So essentially, We're going to learn about modules later when we learn about imports. It's going to be today, right? And modules are also objects. And then inside the modules, we define objects, right? So we're putting objects inside objects. That shouldn't be too much of a surprise, right? And we can inspect modules as we inspect any object with dir. The most top level object, the top level, right? We don't have to specify. If we say dir, we're going to get the top level. Now you see here we have a built-ins. So inside here there's a module called built-ins that have all the functions, methods, libraries that are available from the start. So I can say dir built-ins, and I'm going to get a lot of stuff, right? Everything that starts with a capital is an exception, and we're not going to touch that till much later in the course. Essentially, it's a way of specifying errors, and we're not going to worry about that in the beginning. All right, but there are a few very interesting functions here. One is reversed, right? The other one is sorted. Sorted, right? There's a max, there's a min, which is interesting currently. All right, and let's not worry about it. And you have already seen len. So len comes from here. And let's not worry about anything else for the time being, right? So let's focus on reversed and sorted. So everything that is available at this level, we can just type directly. So I'm going to say reversed, and I'm going to put a string here. A, B, C, D, E, F, G, H, I. And guess what? Ah, well, we get a reversed object. How to explain this to you? So essentially, we get a reversal of the string, but we get a lazy reversal, right? We're not seeing it immediately, all right? And I guess the same thing is going to happen with sorted. If I see str, is that going to help me? No. Okay, forget about that. We're going to talk about. We have to talk about lists first, and I can show you how we see inside, just to make you just to not completely waste this experiment, right? So I can say empty string join of that reversed thing, and I'm going to get the reverse. Why this work? What does this mean? We're going to learn a bit later, right? And if I apply the same trick to an arbitrary string, but I'm going to say sorted here, right? I'm going to get a sorting of all the letters in this string. Okay, so I'm showing you this because I'm going to want to ignore these two functions, and I would like to write them from scratch, right? So I want to practice our coding on strings at this point by trying to replicate these functions. All right, and why do you need to join there? It's going to be explained at some point. Just bear with me. All right, so that's the target for today. We want to replicate these two. We're going to use the same technique that we used last time. So essentially, we're going to try to use recursive functions. Before we go there, let's also try to use min. So I'm going to say min here, and it's going to give me the lowest letter, and of course there's a max, and it's going to give me the greatest letter, right? And what does it mean, smallest, small or great, when we talk about strings? Well, it's lexicographic ordering, right? It's one that you see in the dictionary, right? So if a string would appear in the dictionary in front of another string, then the first string is smaller than the second one, right? And vice versa. So AB would be smaller than B, right? So it doesn't matter how long it is. And ABC would not be smaller than AB, right? So whenever one is the prefix of another, right, the shortest wins, right? ABC would be smaller than ABD though, and so on and so forth, right? So this would give us what minimum and maximum are. Cool. Before we actually can go and write our program, let's talk about imports and modules. All right, so we're going to start working with files. We have this file called strings.py, and we want to define something, or we want to define some data inside, right? And I'm going to start with something very simple initially. I'm going to say that A is 1, which is perfect Python code. We can save this. Disable Pyland. All right. So this gets saved. All right. And we have a number of ways of running this file, right? So I'm going to exit from here. You see the Python file in here, and let's explore the ways of running this file. Actually, let's not leave it quite like this. I'm going to say print A. Let's say print A equals comma A. All right, and save again. And one way to work with this is say Python the trouble here is that it's a very uncomfortable position for me to type. Whenever I use a laptop, I want to actually have it in my lap, and that's when it works beautifully. So one way is to do this: Python strings.py. Sorry, I shouldn't say Python. I should say this Python. Right, strings.py, and this will execute the file as if we typed it from the keyboard, right? So it will execute this file as if we typed it from the keyboard, right? And this would be what happens in there. A gets assigned with 1, right, with the value 1, and then we execute the print, and the print statement will simply print out this. Right? And that's it. And we come out. Right? But often enough, we want to experiment with the program that we have just created. Right? So I might want to say -I here. Right? Include and be interactive. So we get the file gets run, but right now I'm at the Python prompt. All right, so it's as if I have typed all the code and I can continue to experiment with it, right? So for instance, I can say A here, and I can access the value of A from the file, right? So whatever is in the file, it's as if I typed it myself. It's still available, right? All the variables that we would type ourselves, they would be available for later use. So this is still the case. Right? So this is a very easy way of using Python code. Okay, but sometimes we want yes. This is Windows exit. You don't quite compile it. It's more of an interpreter, right? So whatever command I used before, it's there. In your case, if you're on a Mac, you say just Python 3 preferably, -I strings.py, right? So in this case, the interpreter remains interactive. and whatever you define in your program, you can still access, right? So that's another good way of running. That's most of the time if you just want to do something quick and dirty, but still keep the file, you would do it this way. The third way, all right, is to run Python and say import strings. Okay, so this reads the file from the current folder, runs it, all right, and then this thing becomes a module, and a module is an object. So one thing that I can say now is dir. So let's say dir, and you see that one of the things that is now defined at the top level is strings. And let's look at what's inside strings. String, right? So one thing that you see here is the A that we have defined, right? So I can check the value of A. I can say strings.a. Remember that accessing stuff that is inside something else done via the dot, right? The period. A itself would not be accessible at this point, right? So there's a fundamental difference between the -i here and the import. Because -i reads the program as if it were typed. And all the variables that you have in that file, they go into the global namespace. They will go into the built-ins, where the built-ins are, right? Whereas, if you import strings, right, they will go inside a module with the name of the file, right? So you have to operate with these entities a little bit differently. Nevertheless, if you want still A to be inside a global namespace, you can say from strings import A. If you do it this way, then A becomes part of the global environment. You can bring anything from the module, but you don't need to prefix with strings anymore. Okay? Yes?
May I know how to set the directory in terminal?
CD. You're on Mac, right? So CD, and go to the place where you put the file and run Python there.
Okay. So I just type in the file name?
No, the folder where it,
The folder.
well, what do you use for an editor?
Sorry?
What do you use for an editor, for a code editor?
Oh, I was using still idle.
Oh, you're still using idle. That's not good. You need to switch to an editor.
Okay.
All right. So what is your background? I should have asked last time. What's your background? What are you studying?
Oh, physical sciences, chemistry.
Okay, so you'll need to learn this stuff because you're gonna at some point need some level of coding. How about the rest of you? How many of you have science background at least? No, nothing, zero. Science. Okay, what kind of science?
All kinds of science.
Oh, all kinds of science. Nobody is coming from math. Oh, you're coming from math. So then you should.
And science.
No, but then you should learn this stuff. This stuff is going to be useful. Okay, so yeah, you need to learn a little bit more about your computer. So folders. I'm hoping you understand folders, right? Navigating from the command line and text editing. What do you use to type text usually? Sublime. That's a good one. What else?
Notepad.
Not bad. That's good. That's good. Hmm? Text edit is good. Yeah, if you put the py, text edit will know what it is. Don't use Word. All right. Don't use anything that allows formatting. Okay. So so are you getting there? Maybe you can come at the end of the class and I show you everything you have to do.
Okay. Because when I type it in, it says syntax error.
When you type it in,
When I type CD with the folder.
CD space
Yeah.
and it says syntax error.
Yeah.
Where do you type it in the terminal?
In the terminal.
That's unusual. Oh, but you're in Python. So CD, where's your
It's just desktop.
okay. All right. Desktop CD Python. All right, and that's so now if you're in Python 3, you say import. Where were you? What?
I just had this too.
Yeah. So also don't use spaces.
Okay.
So rename them to not have spaces, and then you can say import. Lecture 1 and lecture 2 were like .py files. Anyway, we're recording this, so we're gonna have the recording. You can replicate. So everybody is more or less clear about the distinction between the various ways of running Python and how we can. We're going to see how we can take advantage of them, but I want you to not be surprised. Now, so these are our files that we're importing, but Python comes with a very extensive library, right? And because this library is so large, it doesn't load from the very beginning, right? Otherwise, loading Python will take very long. But we can import selectively a lot of stuff, right? And I think we've seen last time import math. Did we do that? I think we did an import math last time. And then we can say dir math once we have imported it, right? And we can see some of the mathematical functions that can be useful, right? So then, for instance, if you want to get the logarithm of, or if we want to know, for instance, the value of pi, right? We can say math.pi, and we get the value of pi, right? Alternatively, we can say from math import. So just to make it clear, pi as a standalone keyword doesn't mean anything right now, right? But we can say alternatively from math import pi, right? And then now we can say pi as a standalone keyword and it has value, right? And you've always seen the import, this import before this import in all the examples I've given so far. They're completely independent, right? So if you're going to use the second one, you don't need to use the first one first, right? You can completely. I can't undo an import right now, so I can't say unimport math. This is going to be there. But in a fresh session, if I don't say import math, and then instead of that I just say from math import pi, that will still work as expected, right? So it is very typical that we import exactly what we need. Now, when we import, we do an import like this, it is still the case that the entire module gets loaded. So we're not saving space, but we are not polluting the global namespace with keywords we don't need, right? So for instance, if I don't need logarithm and I don't need power, no need to import those because they will just Later, maybe I want to name my own thing POW, right? And now I have a name clash. And so we prefer to be very selective in our imports. Now, and that's for practice. Now, in plenty of cases, just to save time, I'm just going to import the entire module and use it in that way. But just remember the rule. Cool? Yes? So let's try to write some interesting code now. So I'm going to go here, discard this. All right, and let's define a max string. All right, so we take in a string s, and so now we have a string, right, which has many characters, which are indexed, right? So first of all, let's define a function m, and we're going to define it in a nested way. So this is a very interesting thing. I'm going to have m of x and y, right? And we're going to say return. So I'm going to say mx for maximum. Maybe mn is going to be minimum. Mx of xy is x if x is greater than y, else y, right? Remember what we learned last time? So notice that this function is nested inside this one, which we haven't finished yet. And the editor does some code folding for us. All right. So this is very useful again, because I don't want to pollute the global namespace with a lot of names. So the name mx is sort of like a helper, right? And then let's think of what situations, what kind of cases do we have for s? Well, in most of the time we're thinking s can be empty or not empty, right? So does it make sense to have the maximum of an empty string? No, right? So whenever we have an empty string, we return none, right? So we're going to have a return statement here, and now maybe it becomes apparent why we do need the return statement in Python, because we might want to have local definitions like this one, right? And we want to differentiate between when we have a local definition and when we're actually having the return value from the top level function, right? So that's why return is useful. We're going to have several cases, right? So one is none if len s equals 0, else, right? What if we have a single character inside? So we're computing the maximum of the string, right? So if the string has only one character, it's that character, right? So else we're going to return s 0 if len s equal 1, else. So if we have more than one character, what do we return? Mx of, I need arguments here. I need two arguments. Who's x and who's y? you see, this x is valid only up to here. Once I cross that point, x is not known. Right? So this kind of goes without saying, but there's a notion of scope. So this function definition lasts only on the highlighted portion, right? So any variable I define, such as x and y, will last up to the end of the definition and will not be known outside. They are supposed to be formal arguments, not actual arguments. All right. So I can say mx between, right, s0 and max string s1 till the end. Okay? Let me close this. Does it make sense? So let's learn a new trick. Whenever we have long lines in Python, we can use a backslash, and immediately after the black backslash, you have to be very careful with that. You can put a space, right? So be very careful. Something like this is not good. If I have a space here, that's not good. So we can say non-if, right, else, s0, if, else, and then this makes it a little bit more readable. All right? So we're returning none if the length is 0. Makes no sense to say that an empty string has a maximum, right? But if we have a single character right, len s is 1, then for sure s0 makes sense. So by the way, go back here, right? So if I have the empty string and I index it with 0, I get an index out of range, right? There is no character at index 0, so we're going to get an error. As soon as I put a character here, the index 0 makes sense, right? So this part here allows me to write this expression here and expect it not to fail. All right? So as soon as I have more than, what's left here? More than at least 2 characters, right? So what do I do if I have at least 2 characters? Well, I can separate it between the first and the rest. The rest is a string. So to that string, I can recursively apply, so the rest, this is the rest, right? This is the rest. And that's a string, right? To that string, I can recursively apply max string. And I get a maximum for the tail, right? And now I have the first character and the maximum of the tail. So the maximum of the overall string is going to be the maximum between the first character and the maximum of the tail. Is this clear? Yes, no, maybe, yes.
Okay, so how does the max string in the one you're highlighting work?
Again?
How does that just take the rest and then work?
Well, we already seen that, right? So if I have S is ABC,
Yes.
right? S of 1 and the rest is BC, right?
Yeah. So, but how does it evaluate 1, 2? What's the output that gives you the max?
Oh, it's going to be C, right? So if I'm in this case, when I call max string of BC, it's going to give me C, right? So let's say that this is ABC. this S is ABC, right?
Yeah.
Then this is going to be BC. Then this max string is going to return C. And then I'm going to take the max between A and C, which is still going to be C. Right? Everybody's clear with this? It's just math. You can't, this is not programming, it's just math. Cool? Yes, no, maybe? Some people are looking like...
So it works even if it's not just two errors, right?
It works even if it's not just...
Not two layers.
Yes.
Okay.
Cool? All right, let's try to run this. So we save, and we're going to go in here, right? I'm not sure whether I have to, so let's try to import without restarting. One possible problem is, and we're going to say from string import max. Yeah, so why do we get the error? Because we already imported string once, and that's already cached, and it will say, oh, I'm not going to read it again. And as I'm looking at whatever I have cached, there's no max string in there, right? So unfortunately, we have to exit. And then go again. And then luckily, we get our command saved from string. Actually, we wanted to import it from strings. Maybe that was the error. Okay, so we have imported it, and now we can test it. Max string, and we're going to type a lot of random characters here. Some capitals, all right, evaluate this, and we get a character which is the maximum. All right, now how do we verify that this is correct? Well, we can get it from the max, and I'm going to copy the string. So we have the predefined function, luckily. It's not always that easy, right? But sometimes, how do I copy and paste here? Copy, enter, and paste. Is it Control V? Yes. Right, and we get the same result. Okay, we should test that when we get the empty string, we max string, we get none. So none, if you remember, doesn't get printed. Okay, so there's no error when we call it, but we also don't get any result. On the other hand, if I say x equals, right, and now I say print x, I get the none that I was looking for. Okay, so another way of making sure that it works correctly would be to actually write tests. So right here in the file, we can actually check for a variety of values that the result is correct. So I can say print max string of and my random string. Well, let's not type it twice. So I'm going to say test1 equals, and take this from here, put it here. So max string test1 equal max test1, right? Then I can say test2 equals, and I will have some single character here. And again, we're going to say, right? And we're expecting true for all these values, right? So if we have done this, then it doesn't matter much how we run our program, right? So we could exit from here, and I could say simply Python strings.py, and you see true, and it means that what we got is what we expected. Then I can say -i, and then I get the true, right? But now, if I want to continue testing, I can I can take advantage of this. So you see, max string is here, test1 is here, test2 is here as well, right? So I can keep testing, and I can also exit, run it by importing, right? I can say import strings, right? And you see that the true still gets executed no matter what. And when I was telling you that the entire module gets loaded, this is what I mean. Absolutely all the code gets passed through the interpreter and run, right? So this def that you see here defines a function, but this code that you see here is direct running, and then if the module gets loaded, that code gets run. And then while we're here, right, I'm going to have a module called strings, and inside strings, I'm going to have the max string, test1, and test2 that we may want to play with, right? So it's always a good idea to write tests rather than do interactions. Why? Because then you can run it as many times as you want, and you don't have to type again. You type them once in the file, right? And we're going to adopt that strategy. In general, you like to be trigger happy and see that it works very quickly, and you don't want to type a lot before testing that it works, right? But then if you just type from the keyboard inside the interactive environment, when you want to do it again, you pretty much have to type it again, right? So writing it in a file is a lot more economical. Okay? Now, let's try to sort, right? And because we have written a max, we're gonna sort in decreasing order. What if we want to write a min? We wrote a max. Let's try to write a min very quickly. And actually, let's copy the whole thing. All right, so we want something that is called min string. We have an mn here. Return x if x is less than y, right? Else y. And return none if len s equals 0. S0 if len s equals what, right? So if there's a single element, that element is also the minimum. And here we just have to return mn, S0 max string 0. Let's call this test 4, and then what we want is min string test 3, right?
Don't
Test.
you have to change the max string to min string?
Pardon?
Don't have to also change the max string. The max
Yes,
string
very good. Excellent. That means you're paying attention. I'm focused on putting everything in the 2 hours, in the one and a half hours we have. So that's why I'm rushing a little bit. So min here, but thank you for that. And this is test 4, right? And so one thing I want to try is now try to import strings again and see if this is going to change. Yeah, you see it's already cached. So no matter what, if we change the file, we have to exit and start again. And then in that case, it's easier to just run it this way, right? I don't want to interact directly anymore. So now you see that we have true 4 times, right? So it means that everything works correctly. We correctly compute the min. So I want now to sort. Okay? So in order to sort, there's another function that we need to learn. And that is, do we have a remove? Remove, delete. So we have a find. But actually I don't want a find, I want an index. Do you see it? Oh, index. All right. So what does index do? So I can say A, B, C, D, E, F, G, index of C. And I get 2. Right? And it computes the first index from the left. Right? And let's say I have another C here. I still get 2, right? I get the first index from the left. All right? So now if I have this index, right, I can say S is this, and then I can remove C from this index by saying right, index is S dot index C, right? And then I can say S up to I so I'm introducing a new thing here, concatenation of strings, the plus. S I plus 1 up to the end, right? So now I have the original string from which the first occurrence of C has been removed. Is this clear? Yes? Does that make sense? Is this okay? All right. So, def sort, and probably we won't have time for reverse. We're going to do it next time. So we have def sort of S. All right, and we want a function called remove. So def remove, and we want to remove a character C from it, right? And then one interesting thing now here is what happens if the character doesn't exist, right? So S dot index of Z, for instance, right, will return an error, right? So we have to be careful that whatever we remove, we have to make sure that it is inside, otherwise there's a risk of error. But we're going to make sure of that, right? So whenever we pass in a C and call this function, we're going to assume that it's something that exists inside S. So we're going to say that I is S dot index C, right? And then we're going to return S up to I exclusive, right? Plus S I plus 1, I plus 1, come on, can do it, up to the end, okay? So again, you can see that the return is very useful because on this line, we just want to define a value that is used twice here. So I have one occurrence of I and another occurrence of I, right? I could have written s.indexc in both places, but that would have been a waste, right? I want to save typing. So I'm defining s.index to be I, and then I use I twice. That is less typing. All right? So if we have the remove, okay, let's focus on the sort. So if I have the empty string, so again, what are the cases for S? Well, it could be the empty string or non-empty, right? So if it's the empty string, the sorted version of the empty string is what? The empty string, right? If else, so we're sorting, right? The first character of the sorted string should be min string S, right? That should be the first one. Yes or no? We're sorting increasingly, right? We want all the characters in increasing order, right? The very first character in that sorted string should be the minimum, right? And what's after that? Well, we're gonna put something in, but one thing we can do is, since we put the minimum first, we should take out the minimum from the string S, right? So we could have remove of S of min string of S, okay? Yes? And then, so this is the original string from which I have removed its minimum, its current minimum. What can I do with this string? So necessarily this is a smaller string, right? It's smaller by 1. What can I do with this string? But it's a long string. Can you take advantage of something that we already have?
Can you just put it back?
Yes, of course, right? So that's the whole idea. We can sort it. And there you go. And this is what we actually return. I should have put it here. Okay, does this make sense? So we're returning empty if we have the empty string. Otherwise, the first character of the result is the minimum of the original string, right? And then I remove that minimum from the original string. Whatever is left, I can recursively sort. Make sense? Cool, save, right? And let's write a test, right? So let's print, and I'm going to say, because it's a lot of printing now, so I want to make sure that I'm looking at the right thing. And then print, and then we're going to say sort of, all right, this would be test 5. Let's extract it in a variable. test5 and equal. And remember what we used before to have a tested string, right? So I could take this and say join sorted. All right. So this is a way that the system allows us to verify. We're going to accept it for the time being. I'm going to explain at some point what it means, but let's just for the time being, let's just use it. Join 5. Okay. And we can go and you see me typing Control D because that would work in on a Mac. All right, so we have a small error. File strings, it says unexpected indent. Okay, yes, because we should have a backslash here as well. So I get true, right? Which means that the result is correct. You can do it as long as you like, right? Control C, Control. Let's add more tests. So one interesting thing is the empty string. Another interesting case might be seven, right? The same character everywhere, right? So let's say we have zeros. And yet another interesting case might be a string where everything, it's ordered in reverse. Z, Y, X, W, V, U, T, S, R, Q, P, and probably enough of them. So this would be test 8. Okay, so we can do this again. Everything is true, so it works correctly. Okay? Okay, let's see very quickly. Can we do reverse? So we don't need any helpers. This one is actually quite easy. So again, we have two cases. The reversal of the empty string is the empty string. Very good. What if we have a non-empty string? What's the last character of the reversal of the non-empty string? The first character of the original string, right? So I'm going to have something plus s index 0, right? S index 0, which is the first character, right, will necessarily be the last of the result. What do I put here? Reverse string Well, do I need to?
1.
Yes, 1 up to the n, right? This is it. Yeah? So test 9. I think I will need to bring a separate keyboard and mouse, which is sad because this tablet is so small and cute. It would have been nice to be self-sufficient. So A, B, C, D, E, F, G, H, I, J, K. All right. So let's separate. Okay, so we want to see it printed just for curiosity, and then we can say print reverse string of test 9 equal, and we have the same thing, right? Join, and it will be explain soon what it means. All right, so it's almost the end of the class, so let's do just one test. All right, and right, you can see it reversed here. Right, and the test is true, so it means that it is correct. So is it clear what we're trying to do here? So again, this is math. This is not programming. I mean, it is programming, but by virtue of mathematics. The original notions of computation they were defined mathematically. You might have heard the name of Turing, right, who's the father of computer science. He worked with his PhD advisor, a guy named Alonzo Church. And together they essentially defined the foundations of computation, right? And they went in very different approaches. Turing developed his so-called Turing machine, whereas Church developed the notion of recursive functions, which is exactly what you see here, right? So, and then they disagreed with whether they were equivalent or not. Each of them thought that their own mechanism is more powerful than the other, and ended up by proving that they are equivalent, which was one of the fundamental theorems of computer science, right? But the very first way of defining, one of the very first ways of defining computations was via recursive functions, which is what you see today, right? So in a way, we are reliving the history of computer science. This type of programming ended up being formalized into a calculus called the lambda calculus, all right, which became the foundation of functional programming, of which you might have heard. Cool. That's the lesson for today. So if you have any questions, feel free to stay over, and I'm happy to help set up our computer or answer your questions. Otherwise, thanks for coming. See you next time. On your way out, please turn on the light.